Hello friends, welcome in my channel. I am Rashid and today I am going to show you how to calculate voltage drop calculation for a street lighting. So first of all I am writing here the voltage drop formula. This is VD is equal to I into L into VD by 1000. Where VD equal to voltage drop in volt. I equal to this is load current in ampere. Now we move to L. L is the length in meter, cable length in meter, and this VD, voltage drop per ampere per meter as per cable. VD equal to voltage drop per ampere per meter as per meter as per cable. In street light, generally we use 4 core 10 mm square or 16 mm or 25 or 35 mm square. Actually, it's depend on the load and the circuit length. So VD for 4 core 16 mm square cable is 2.2. Writing here VD for 4 core to 16 mm square cable is 2.2. Actually, this is as per Karama standard. You know, Karama is the electricity board in Qatar. So, if you guys from other country, you should follow your own electricity board guidelines. This value is almost same or minor difference if we compare to the other country. Same for if we calculate for 25 mm square cable, 4 core 25. So I will write here VD for 4 core 25 mm square cable is 1.5. This is the constant we will use in the formula. This constant. So as per the above formula, we have to find out the current value. So first we write here current I equal to P divided by root under 3 into voltage V into cos phi. This is power factor, where I mention V equal to 415 volt. This also as per Qatar standard. Here we are using 415 for 3 phase. Then P equal to power in kilowatt, and cos phi equal to power factor. We use here 0.9, so I will write here 0.9. Then put this all value to achieve the current. I equal to P divided by 1.732. This is the value of root 3. Then multiplication by 415. This is voltage, and multiplied by 0.9 power. This is power factor. After this calculation, we get this value P by 646.905. You can calculate. You will find the same answer. Or make it more simple. After dividing this, we will get. I will show you here. I equal to P power into 1.55. If you calculate, if you divided this value 646.905, you will get 1.55. So this is the value of current which we will use in the voltage drop calculation in Excel sheet. So next I am writing here total watt considered for 250 watt lamp, because we will use in our calculation 250 watt lamp. So for 250 watt we will take 275 watt. This why it's become 275, because we added 10% safety factor. So 250 plus 10% safety factor. Safety factor. If we added this 10%, you will get this value 275 as the above, as you can see here. Yeah, this CAD is open now, and here I am showing you how to calculate. First I make a rough drawing for you for street lighting. Let me draw. Let us suppose this is a street light. Make it copy and paste like this. Yeah, I think this is enough. 1, 2, 3, total 9 street light. And it's better we will put to feeder pillar also. This is the feeder pillar panel. Right, 4 core 16 mm square cable, as we assumed 4 core 16 mm square. And just as usually we use in a street light the lamp wattage 250 watt or 400 or 600. It's depend on the client requirement. So I assume here 250 watt. 250 watt. And this is filter pillar. I'm just naming this 01, filter pillar number 01. Okay. And the second thing is we have to mention the length of the cable from pole to pole, how much length. So just assume it. Suppose here I mention 5 meter. Here from this pole to that pole 40 meter. From that pole another pole distance is 42 meter. Actually it's depend on the client drawing and site condition. 45 meter. And also 40 cm, 45 meter. Here I mentioned, so just you can mention any number like 42 meter, doesn't matter. Here I mentioned 6 meter. 7 meter. And last one, I just mentioned 46 meter. It's up to you. Or as per the drawing, you can mention the length of the cable. This is the final drawing, street light drawing. So as per this drawing, we will calculate our voltage drop calculation. I will show you in the Excel file how to calculate. So guys, I prepared this Excel sheet in which I mentioned circuit number, power, current, length, and constant. This is 16 mm square, and VD voltage drop formula, and this is the percentage. So now we will mention here circuit number, all the values I have to mention here. So first we open this CAD drawing in which you can see here I mentioned the name of all points, name of all the poles. So R1, Y1, B1, R2, Y2, B2 like this, and this is the feeder pillar FP01. So I should mention here feeder pillar, we should give the naming of the circuit and pole. FP01, R1, then next one FP01, this Y1, and FP01, B1, yeah, and so on. Copy and drag it down till B3, yeah. So we have to mention here the wattage. Now we have to put this value in kilowatt. So and we have 275 watt each luminary. So we have to convert into kilowatt by divided by 1000. So the value is 0.275. At each point, how much wattage is consumed. So we can see at R1 point. R1 point it has connected with 9 numbers of luminaries. R1, Y1, these all are luminaries. So R1 has 9 numbers of luminary loads. Each has 275 watt. So we will multiply 9 into 0.275 kilowatt. So now we will do the same procedure at Y1 point. At Y1 point, total 8 numbers of luminaries has connected, that is B1, R2, Y2, B2, and so on. So in this case, what we will do, we will minus 1 luminaries load from the above value. So we will minus 1 luminaries, that is 0.275. Same way we will do at points. So for shortcut method, drag till B3 point, and at the end you will see at B3 point the load is 0.275. Here you can see at B3 the load is 0.275. It is the same as each luminary's wattage. Now move to find out the current at each point. You remember we derived formula I is equal to P into 1.55. This is the formula here. I is equal to P into 1.55. So we will use here, we will get P from here, from this kilowatt value. We will multiply by 1.55. Now we will write cable length from point to point. So first we will write here, that is 35 meter. And the second R1 to Y1 is 40 meter, and so on. 42 meter, then 45 meter, then R2 to Y2 45 meter again, 42 meter, then B2 to R3 sorry, 40 meter, 46, and that is 47. This is 46. As I told you, the constant of 4-core 16 mm square cable is 2.2. So we will write here and copy and paste, because all cable has the same size. So finally we got all values for the point R1. Now we will put in all these values to find out voltage drop. So we will copy this We will multiply these all values divided by 1000. First we make a bracket and then whole divided by 1000, and the value comes 0.30. This is the total voltage drop at this point. Now we will do the same procedure to find out current at point Y1. So power multiply by 1.55, same as before what we did, 1.55. Now the voltage has dropped at this point 0.30. You can see here 0.30. This is the voltage drop, and here current will be calculated in the respect of remaining voltage, not 415 volt. We will minus 415 minus 0.30 volt. Then in respect of this voltage, we will calculate this current. So now the source is R1. Here the source is R1. Yeah, before the source was this feeder pillar, that is 415. Now the source is R1 for Y1 point. So now the source voltage become 414.7, because if we minus from 415 minus 0.30, you will get 414.7. So we will do the calculation as per this. Yeah, I can show you here. 415 minus 0.30. Yeah, 414.7. So add from R1 to Y1. Source is R1. So we will make calculation. C5 into 1.55, bracket close, bracket close. Now multiplication, again bracket, 415 minus 0.30, 0, one more bracket should be here, 0.30. Yeah, we can copy and divide it by 415. Well, this is the total voltage. Now the value become 3.41. This is the current value at the point Y1. Now we will get all this value, so we can find out the voltage drop at this point. Voltage drop at Y1. So same procedure. We will calculate above voltage drop plus voltage drop at this point divided by 1000. The total voltage drop is 0.6. So through this way we can make our all calculation. So we can easily track till B3. Voltage drop also same till 1 point. Now we will find the voltage drop percentage. Voltage drop into 100 divided by 415. This is the percentage. Let me change the format. Yeah, it is 0.7%. Yeah. So finally we get this value 0.42. This is the maximum voltage drop percentage, and 1.75, this is the voltage drop at the point B3. So the maximum allowable voltage drop is 3%. If drop become more than 3, then we must change the cable size until the drop become less than 3%. So thank you guys. Hope you understand how to calculate voltage drop for a street light. Please subscribe my channel so that I will make more videos regarding a street light. So thank you very much.